Uh, Good afternoon, everyone. So today I'm going to start with composites, and we have started with Unit 2 and complete Unit 2. So Unit 2 deals with the study of ferrous materials and how to improve the properties of the ferrous materials, like secondary heat treatment process, secondary processes like heat treatment. We have seen heat treatment process for both ferrous as well as non-ferrous materials, and also we have seen the non-ferrous materials heat treatment, everything. So now I'm going to start with the composite materials. So as we have seen in earlier classes, like in the first unit, we have seen the different types of materials. So one among classification is the composites. So we have seen engineering materials. This engineering materials was classified into metals. Again, in these metals, ferrous and non-ferrous. Ceramics, polymers, composites. Okay, so again this is non-metals. So in this wood everything it comes. So ceramic, polymers, again polymers, thermoset and thermoplast. Okay, so I'm going to start with now composites. Once I complete the composites, then we'll come back to polymers and ceramics, because this composites majority consist of ceramics and polymers. Okay, so what is this composites? Okay, so this composites is nothing but it's a combination of any of these metals. So it can be a combination of this and this. It can be a combination of this and this, or it can be a combination of this and this. Okay, so in general these composites are classified as matrix, reinforcement, dimension, and this is orientation. Okay, so this composites is again sub-classified on the basis of matrix, reinforcement, dimension and orientation. So now when we talk of this composite, this composite is nothing but it is the study of minimum two different materials called as matrix plus reinforcement. So there are two different materials are required. So those materials are called as matrix and reinforcement. Both together, when we mix matrix and reinforcement, then it is called as composites. Okay, so the basic requirement is two, that is matrix and reinforcement. Now let us see what is this matrix and reinforcement. So what are these types of matrix? So these types of matrix is PMC, that is polymer matrix composite. Then it is MMC, that is metal matrix composite. Ceramic matrix composite. Then it is carbon-carbon composite. Then the last one is inter-matrix composite. So these five are the general type of composites based on the matrix. So it is nothing but polymer matrix composite, metal matrix composite, ceramic matrix composite. This is carbon-carbon composite. Next is inter-matrix composite. Okay, so we understood in earlier class in the first unit or here. So matrix composite requires two different elements like matrix and reinforcement. So here the matrix is subclassified as polymer, metal, ceramic, carbon and intermatrix. Now let us study about this what is matrix. Now let us study about this matrix. What is this matrix? So matrix is a base material. Okay, it is also called as bulk material. It's also base material and the bulk material or the high volume material. Okay, so these are the base material and this reinforcement is nothing but the additional material or it is an substitutional material or this is bulk and this is in small quantity and this is low volume. Okay, so now when we combine this, then what we will get? We will get this composite. So what is the requirement of this composite material? So for example, you can take the property like this. Now this is the stress, this is the strain. Now I am going to take the matrix properties where the matrix is base material or it is bulk material and it is very high volume material. Assume that the strength of that matrix material is like this, that is you can see this is low strength whereas this is high ductility. So this material is matrix material. Now there is one more material, okay, so which is having very high strength. This is the reinforced material where we can see the strength is very high strength but this is very low ductility. So there are two materials with the two different characteristics. One is very high strength, other one is very low strength. But one is having very good property like high ductility where this is having high strength. But whereas the drawback of this is what? Low ductility, where the drawback of this is low strength. Now in any of the case, if I can combine this high density, high ductility of this material and high strength of this material, if I can club these two material which are having the better properties like high ductility as well as high strength, okay, so the weakness of this and the weakness of this have been overruled or overcome by a term called as composite material. Now the strength of this, when I combine this reinforcement and matrix in both, then this is called as composite material. So what I have done, the advantage of matrix material and the advantage of reinforced material, both I have combined, then it is called as composite material. Now I can see I have compensated little bit strength, but what I gained is more ductility. Okay, so this type of requirement is called as tailor-made material. So generally a composite material is also called as a tailor-made material. Means, so in this case it is matrix is having a set of predefined properties where I can't change from the primary manufacturing process. In this also the properties are predefined where I can't change the properties of this. But if I combine the advantage of this and the advantage of this, then I can increase the strength, I can increase the ductility and also increase the strength. So the advantage of this and the advantage of this both I have combined and then got the composite material. So now you can say, so this composite material, so it can be here and it can be here also. So why can't it be here? Why not here? Okay. So this composite material is having the variable parameters from here to here. So it can come here, it can come here, it can come here, anywhere in between the matrix and reinforcement. So here is reinforcement and here is matrix. So it can come here anywhere in between. So what are those parameters? So these parameters are variable parameters like what type of reinforcement, for example like whether you are adding metal, whether you are adding ceramics or polymer, so based on that it is going to change. Second one is what shape of reinforcement you are going to add, that is round, irregular, whiskers, okay, regular size, irregular size, based on that. Then is what size you are going to add, for example this, okay, again the property will change. And after this, what manufacturing process you are going to use. Okay, for example now you want to manufacture a simple block or a simple sphere. If it is manufactured by casting process, the properties, the shape and size are same, but the manufacturing processes are different. For example, if you want to manufacture a sphere, so by casting the size and shape, the properties will be different. For the same size, same shape, if you are going to manufacture by the forging, the property will be different. By powder metallurgy, it will be different. By rolling, it will be different. By extrusion, it will be different. So even though the shape and size is same, by changing the type of manufacturing process, the properties will be changing. So these are some of the variable parameters which influences on the final set of property of the composite. So hence we can control each property very minutely. So that is why it is called as a tailor-made material. So a tailor-made material is nothing but a composite material. So for example, if I have the steel, so steel will be having certain strength. So if I want to increase or decrease some properties, okay, selectively, I can't do it. So then I should go for other alternate material. Again, that particular material will be also having a set of characteristics. For example, if I want to have the property in between the steel and the aluminum, so I can't have much variation. So in composite, I can have the desired properties. So this, by these variables, I can get the desired manufacturing or desired set of properties. So that is why it is called as tailor-made material. So a composite is termed as a material which combines two minimum materials. So one is matrix phase, other one is reinforcement phase. So the matrix phase is very ductile and more in volume. Generally it will be having the less properties and because of its low density. So now we are going to add some smaller element to it in the form of reinforcement. By adding smaller amount of reinforcement, the property of that base metal will be increasing. Okay, So that is called as composite material. So based on this matrix, so this matrix is called as polymer, metal, ceramic, carbon and intermatrix. Okay. So based on reinforcement, it is whiskers. Okay. So then it is flakes, then fibers, okay, then particulates. Okay. So these are the different types of reinforcement which are added in the matrix material. Then is dimension. So this is one dimension, two dimension and three dimension. So one dimension is the material is aligned, or the reinforcement is aligned in the matrix only in the x direction or in only one direction. If it is in two dimension, that is x and y. If it is in three dimension, that is x, y and z. Okay. So this is the dimension. Next is orientation. So orientation is continuous, discontinuous and random. Okay. So continuous means, assume that this is the material. So the material is, the reinforcement has started from this start to end. In a discontinuous, it is not from start to end, but it is like this. Okay. In random means it is arranged in any fashion order. So this is the continuous from start to end. Discontinuous, okay, it is not in a continuous form. Some in between there is a breaks, and these are random. So there is no direction and orientation, just they are dispersed randomly. So a composite material, the properties can be defined or modified based on these conditions. That is, what matrix material you are going to use, what is the type of reinforcement you are going to use, and what shape you are going to use, then how these reinforcement are aligned in the base matrix or the base metal or in the bulk material. So whether it is in the order of one dimension, two dimension and three dimension. So next is continuous, whether that alignment of reinforcement in matrix is continuous, discontinuous or random. Now you can see in the steel structure, that is the column and the beams, where the reinforcement is in the form of steels. So from in the beam from one end to other end, the fiber, that is reinforcement, is continuous. There is no break in between. Like similarly, if you can take the plywoods, which is used for the doors and commercial applications like benches and other things. So there the arrangement is not continuous, but it is in the form of random. So now this is discontinuous, where you can take a ice cream or a biscuits, where you can see some cherries are dispersed in the biscuits or in the ice cream. So those are not oriented in a perfect position or in the perfect location. So there it is just dispersed randomly. So in each case, even though the material is same, so the orientation in the material, if it changes, then the property will also change. So that is how the composite properties can be varied based on these conditions. So a composite material are classified based on the matrix, reinforcement, dimension and orientation. So in matrix, it is polymer matrix, metal matrix, ceramic matrix, carbon-carbon matrix and intermetallic composites. Next, based on the reinforcement, that is whiskers. Whiskers are very big in nature, which is irregular shape. Flakes are smaller in shape. Fibers like continuous fibers, long fibers, short fibers, all these. And the particulates are very small in size. Okay, so these. Next is dimension, 1 dimension, 2 dimension, 3 dimension, continuous, discontinuous and random. Now you can see here the property of an material, okay, can be varied by this diagram. So now let us see one by one. Okay. So these are, when I draw the stress diagram for a tensile test, the matrix and reinforcement. So in between I have the composite material. Now we'll see one by one. So this is controlled by, as we have discussed earlier, that is the what material I'm going to use. Then based on what shape I'm going to use. Then what size I am going to use. Then next is what process I am going to, that is manufacturing process I am going to use. Next is what orientation I am going to use. For example, now let us see, there are like in this material there are polymer, okay. Next there are metal and ceramics, okay. Next shape is, that is spherical, okay, irregular and regular. Regular can be of these are regular, okay, all these are regular. So the size, so small, medium, large. Process, orientation, whether the fibers are aligned in this order, that is 0 degrees, or whether it is aligned in 90 degrees or any degrees from 0 to 90. So now let us see one by one. So as we have discussed, suppose if my matrix is polymer. So what are the characteristics of a polymer? So we know that the melting point of polymer is very less. So maximum around regular polymers is from 120 to 150, that is max. So like commercial and industrial polymers go up to 250, 300 degrees centigrade, but the usage of that is very limited. But general purpose plastics are the maximum is 120 degrees centigrade. So all our water bottles and the water cans, oil cans and any domestic applications, so which are made up of polyethylene and polypropylene, so the maximum temperature is 120 degrees. So it melts and completely the shape and size has been lost. So now we can say that polymers are having very low melting point. At the same time, the polymers are also having very low strength. The strength of polymer is very less. So if you are going to apply some little more force, then it is going to bend. So it is having low strength and low melting point. So the usage of that is also very limited. Now by chance I want to increase the strength of polymers. Okay. So if I want to increase the strength of polymers, then how do I do? So I need to go for another polymer, leaving this polymer aside. So because the strength of this polymer is very less. So by any chance, the strength of this polymer, I could be able to improve the strength of this by adding any of the another polymer. Okay. For example, there is a polyethylene is a type of polymer which is generally used for the drinking water bottles and this cold beverages water bottles. Now if I want to increase the strength of this polyethylene, then I should add one more polymer called as ether ketone. So it becomes polyether ketone, that is peak. So adding another high value property of polymer, adding to the low value of polymer, then it becomes both matrix is also polymer, reinforcement is also a polymer. Then these type of composites are called polymer composites. Okay. So if in the polymer, if I am going to add this metals, okay, so I can add smaller fine size particles, maybe around 400 to lower micron size. So I can add in the polymer and I can convert this polymer. The basic nature of polymer is a insulator. By adding some percentage of the metals, it can be converted to conductive polymers. So a polymer which is basically insulative in nature, it can be made as a conductive. So that is called as polymer metal composites. So the matrix is polymer, so the reinforcement is metal. Then if I want to increase further strength of this, then I can go for ceramics. By adding small amount of ceramics to the polymer, I can further increase the strength of the polymer. At the same time, the strength what it is going to take in the matrix material can be almost doubled or tripled when I add ceramics to the polymer. So for example, you would have seen the printed circuit boards, that is PCBs in any of the electronic gadgets, maybe phone, TVs or any electronic gadgets where you are going to have the green color circuit board. Those are nothing but these polymer ceramic composites. Okay. So these are having higher set of properties called as reinforcement, where these are added in the polymers. So by adding these to the polymers, what will happen? The strength, the melting point and the conductivity and the other properties of the polymer will be enhanced. So this type is called as polymer composite matrix. Okay. So as we have seen in earlier case, these polymers can be of two types, that is thermoset and thermoplast. So one is you can recycle and reuse a number of times. This you cannot recycle. It is one time process and it should be processed by the virgin material. So you cannot reuse or recycle the thermosetting plastics. Only you can recycle a number of times of this thermoplast, but there will be degradation of the polymer when you recycle next cycle. Okay, there will be some decrease of 15 to 20% property as compared to the original virgin material. So by adding the high strength material to the lower strength material, the property of the lower material can be enhanced or increased. Okay, so this is called as polymer matrix composites. So next, your metal base matrix is metal. So as we can see, the density of base matrix, okay, that is metal is higher, but you cannot add polymers to this, but metals can be added to polymers, but the polymers cannot be added to the metals. So in this what will happen, the polymers in metals are not compatible, whereas the metals are compatible in polymers. Okay. So if this is matrix, if your Matrix is metals. In this you can add another metal or you can add ceramics. So adding metal to metal, so that is called as metal matrix composite. So you can add metal in the metal. So for example, aluminum is the low strength material. Okay. So germanium is a low strength material, copper is a low strength material, steel is high strength material, titanium is high strength material, tungsten is high strength material, whereas aluminum is low strength material. Okay. Now if I want to improve the strength of the aluminum, so by various alloying or other processes, I cannot increase the strength of aluminum maximum. So I can increase only considerably. So by alloying, so I can increase the properties just by some 15 to 30%. So by composite method, I can improve the properties up to 3 to 4 times. So basically, the aluminum is very soft in nature, low melting point, low strength and low density. Now by adding the titanium, tungsten or steel to aluminum, the property of an aluminum has been increased considerably, like almost 2 to 3 times. Okay, so that is what the advantage. And even you can fix up, for example, as the strength of aluminum is 210 GPa, 210, so you can, if you want 500, so by adding certain elements which are having the high strength, you can get that particular value. So now for the metal, you can add the metal or even you can add the ceramics. So now you would have heard the ceramics, okay, so which are basically insulative in nature where they have very high strength. These ceramics are nothing but oxides. By adding these oxides to metals, okay, what will happen? The strength of metal will be increased. So while the strength of the metal when it increases, so this can be used as a cutting tool. So for in the lathe machine lab, okay, so some of the tools are made up of the ceramic and metals called as cermets. So this and that is metal and ceramic, when both are combined, then it is called as cermets. So ceramics and metals. So both are combined. So this property is very, very hard. So this can be used to do the machining for the materials like steel. So as we can see, the steel is very stronger material compared to aluminum and copper. So by using the ceramic, that is metal and ceramic, you can use to remove the material from the steel material. So that is what the advantage. Okay. So both metal and ceramics can be added to the metals. So this type is called as metal-metal composites or metal-ceramic composite. Suppose in the third case, if your material is the ceramics, so your base matrix itself is ceramics. So in this you can add small percentage of metals or you can add ceramics. That is ceramic composite. So the base metal is also ceramic and the reinforcement is also ceramic. So by this what will happen? The property of the metal will be increased. Okay. So you can even add a small percentage of metal to the ceramics. So the example of ceramic is CBN. That is cubic boron nitride. So here the boron and the nitride both are mixed and used as a tool. Okay. So this tool is second hardest material in the nature. So the first hardest material which is naturally formed is diamond. So as we are aware, diamond is the only strongest material in the nature. But this cubic boron nitride, which is the artificial material, where it is next or almost equal to the strength of the diamond. So this is cubic boron nitride. Okay. So for this even some percentage of yttrium is also added. So by adding this, then what will happen? The strength of basic ceramic will be increased and this can be used as a cutting tool. So the highest the material can be removed by this ceramics. Okay, so this is about the what type of material you are going to add in the base metal. So next, once you fix up the material, for example, now we can select the base is polymer or the base is metal. Okay, this is matrix. Okay, so now in this I am fixed. Assume that this metal I am going to use. So the reinforcement is metal. Okay, so what type of metal? Okay, that you need to fix. Once I fix, what is the shape of that particular metal? Whether it is regular, okay, spherical, irregular, regular, okay, all these things you need to check. Suppose when you use, assume that this is a material, in this when it is spherical, so like this. So now I have fixed metal and metal. So this metal is having this type. So though the material is same, by changing the shape, the spherical, irregular and regular, again the property will be different. So this is considered to be most weakest because here you form a slip plane because it is having a regular boundary. So in this the slip will be more, as when the slip is more the dislocation is more, hence the sliding will be more. When the sliding is more, then the failure will be easier. So in this also here you can see along this the slip plane is more, but where you can see here in the irregular shape the interlocking is there and the grain boundary is getting locked. Hence, though the material is same, by changing the shape, again the property will be changing, the strength will be changing. So this irregular will give better results than this. This will give better results than this. Okay. So though the size is same, the shape is same. The shape is different. So now this will give the first result, this will give the second result, and this will give the third result. Now assume that now I have fixed up this. So what size I am going to use the particulates, whether it is like this, whether it is like this, whether it is like this. So now again I can, in a given set of volume, I can have the smaller particles. So I can have the small, medium and the large. So when I compare this, now I have fixed up the matrix, I have fixed up the metal, again in that metal I have fixed up the shape. Again this shape is, I am relating it to the size. So this size, small, medium and large. So this large will have the very less force, moderate, and this will have the high force. So the smaller the size, the property will be again very better. So now if I want to apply the compressive force or a tensile force, this will take the maximum load. Okay, so now I have fixed up the metal and the matrix, this and this. Now I am going to make a combination of metal, reinforcement, the shape and size. So now once I combine all these things, then how to process it? How to process it? When I combine all these things, how to process and make one complete product? Assume that the product is a cylinder. Okay, so this cylinder, the shape and size of this cylinder, assume that the diameter is 10 mm and the length is 100 mm. Okay, So this I can obtain it by the casting process, the drawing process, extrusion process, okay, the forging process, rolling process. All these process I can apply and get manufacture this particular component, which is a cylinder in nature. But I will not get the same properties even though the size and the length, okay, the shape and size are same in all the cases. So in extrusion it will be different, in casting it will be different, in forging it will be different, in drawing it will be different, and in the extrusion it will be different. Again, direct extrusion, indirect extrusion, in the rolling it will be different. So what is that property I am looking for? Okay, so that also I need to fix them. So next is orientation. So this orientation is nothing but, so when I have, so stress and strain, if the fibers are oriented in particular direction, then this is what? This is 0 degrees, this is 90 degrees. The strength keeps on decreases. So assume that this is my material. In this I am going to place it 90 degrees. Okay. In this I am going to place it 35 degrees or 40 degrees or 60 degrees. In third case I have this. So when I apply the tensile force, then what will happen? My strength decreases. So this is the case when I have the like this. So this is the case when I have the like this. So here, somewhere here, I get like this. Okay. So this is what the effect of orientation in the of fiber in the matrix. This is 0 degrees, 45 degrees or 60 degrees or 30 degrees. So this is 90 degrees. So along the direction the strength will be very, very high. Across the direction the strength will be very, very less. Whereas if reverse the process in compression, this will be very, very stronger. In this it will be very, very weaker, and this will give the moderate results. Okay. So depending upon though everything is fixed up, so what is the test you are going to carry out, what property you are going to look, based on that the orientation will help you to get that particular desired properties. So this is what the advantage of composites. So in alloying, what will happen, you heat one metal to the liquid state, then you add another element which is having the higher strength than the base metal. So you are going to add that in a liquid state and processing it. After solidification you get the metal. So in that case the property of that alloy is fixed. Even though if you do secondary heat treatment process like a heat treatment or a spray coating, galvanizing, nitriding, whatever the process you are going to do, you cannot enhance the properties to a significant level. Only you can increase to the certain considerably smaller limit. So now by doing this composite, the same elements, the processing methods are different. Because of that the strength almost doubles or triples than the base metal. So that is what the difference between the alloying and the composites. Okay. So this is what the general brief introduction that I have given you about the composites. Okay. So just I am going to revise what we have discussed in the today's class. So from the beginning we have seen that composite is a material which requires minimum two different materials called as matrix and reinforcement. Matrix materials are those materials which are having very low properties, low strength, low density, everything will be low. Okay. Whereas reinforcement material are having the very high properties, okay, but they will be very high costly and their processing is very difficult. So when I combine the low strength and high strength material, then what will happen? Then it is called as a composite. So this composite can be defined as two ways. This is metals. polymers, ceramics. So all are independent materials. So if I combine these, then it is polymer metals. If I combine these, then it is metal ceramics. And if I combine polymer ceramic materials. So when I combine these, then it is called as composites. Okay. So composites are the material which brings multiple materials and makes one common material. It's called as composite material. Okay. So this composite material is having two things, that is matrix and reinforcement. Two are the basic requirement. Once I fix up the matrix and reinforcement, I should know the dimension, how I should lay up in that composite, that is one dimension, two dimension and three dimension. If I am going to put only in one direction, that is called as X direction, that is called as one dimension. If I am going to use the X as well as Y, then it is called as the two direction. If X, Y and Z, the arrangement of reinforcement in the matrix material is in the three directions, that is called as three-dimensional composite material. So if it is in the continuous, okay, so from start to end. Discontinuous means in between there will be a breaks. Random means there is no particular order and direction, just it will be dispersed randomly, and that is called as random orientation. Okay. So based on this, the strength of the composites can be varied by these parameters, like you can see here, the matrix is very low strength, high ductility, high strength, low ductility. So now I am going to combine these. Then when I combine the matrix and the reinforcement, I am going to call it as composites. The strength of the composite can be anywhere between the matrix and reinforcement, which is a variable. So I can get the composite strength here, 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 anywhere in between the maximum limit of reinforcement and matrix. So what are the governing factors? These governing factors are nothing but the shape of the material, what type of material you are going to add, what shape of the material you are going to add, what size you are going to add, what process you are going to choose, and what orientation you are going to use. Based on this, the strength of the material can be varied and you can get the desired properties. So these desired properties is called as tailor-made material. Okay. So this is just a brief background of the composite material. Okay. So if you have any doubts, any questions, you can mail me or you can just write to me or you can call me and get to clarify your doubts. Okay. So I'm going to stop here, and for in the coming class, I'm just going to discuss about how to manufacture these composites. Okay. Thank you.